To start off writing equations of special segments, we first need to go over how to write a line or an equation of a line that is parallel and an equation of a line that is perpendicular. So first off, parallel lines, we know, have slopes that are the same because the lines do not intersect each other. So the biggest part you need to remember about that is that our slopes are going to be the same. For perpendicular lines, we know the slopes will be different, and there's two things that will be different. They are opposite signs and they are reciprocals of each other. And this is because the lines do intersect each other. The way the two lines intersect each other is they are 90 degrees to each other, so whenever we've got a 90-degree angle, we know that those two lines are perpendicular. The slopes then will be opposite signs, and they will be reciprocals of each other. So those are the main things you need to remember for the slope of them. When we write our equations of the lines that are parallel to this given line, we are going to go through the coordinate that is given as well. We're going to write it in slope-intercept form and point-slopes form. So what you have to remember is that slope or point-slope form will actually be first, and then writing it in slope-intercept form will actually be second. So for this equation, we need to first write out what our slope is of the original equation. And since we have y equals mx plus b, our slope is this -3. Now, because we have parallel slopes, we know that this parallel slopes will be the same, so that is also a -3. The coordinate we are going to use then is still the -4, 8. That will not change. Now, when we use our coordinate, this is our x1 and this is our y1. This is the setup we are going to use. We have our point-slope form is written right here. We need to substitute in these three numbers into our three locations. So our slope, remember that is our m value, so we're going to have a -3 for our slope. We will have the -4 for the x value, and that becomes a +4 because it's a minus a negative. For the y value, we have that +8. That's an error up there because we have the +8 here, so we just put our 8 in there. This would be our answer for a point-slope form. Now, to solve for y, to put it into slope-intercept form, we need to distribute first, so that would be a -3x minus 12. Because 3 times 4 is 12, we've got our negative. I carry down the -8. Now we need to move the -8 to the other side, so I'm going to add 8 to both sides. Make sure you put it underneath your like term, so just underneath the 12. The slope should still be a -3, and now -8 plus, or -12, sorry, plus 8 is a -4. So here is our slope-intercept form. That means in our slope-intercept form, our slope is still the -3, and now our y-intercept is a -4. So that would give us some other coordinates we could look at to graph our line. On number 2 now, I want you to go through and fill out some of this information. So our slope, I want you to fill out all three of these pieces. So you figure out what is the slope of this original equation, then what is the parallel slope going to be, and then what coordinate will we use in our equation. And then finally, I want you to put those three numbers into our equation correctly. This is what you should have put now for the slope is -1/3. The parallel slope is also a -1/3 because it's the same. Your coordinate you will use is 3, 1. So now when you put those numbers into the locations in our equation, this is what your problem should look like. There's no double negatives, so that would be your final answer for point-slope form. Now we need to put this into slope-intercept form. So I want you to keep on going on, and I want you to tell me what is your final slope-intercept form equation going to be. When you distribute, you should get a +1, and then you can add your 1 to the other side. So you would end up with y equals -1/3 x, and then +2. So your slope is still the -1/3. Your y-intercept now is going to be at a +2. So moving on to the next part, we have the exact same setup, except now we are doing perpendicular lines. So we want the perpendicular slope to our original equation. But first, we need to figure out what is the original slope. So is it 2 or is it a 7? The 7 is the y-intercept, your 2 is your original slope. Then if I want the perpendicular slope, remember you have to switch two things. You want the signs and it to be reciprocals will be different. So the sign is a positive right now, so we know our answer will be negative. And if I put this over 1 to begin with, if I flip it, that becomes 1 over 2. So our new slope, the perpendicular slope, will be -1/2. The coordinate is the same that they give us, so that goes there. Now we have our equation for point-slope form. We need to fill in the three numbers again. So our y value goes first, that's 11. The slope is in front of your parentheses, so -1/2. Your x value is a -4. So when we put it in there, we have the double negative, so that really becomes x plus 4. There's your first answer. Now we need to distribute again to get our slope-intercept form. So we distribute the negative 1/2 to the x, we get negative 1/2. Negative times positive is negative, and then half of 4 is 2. Your y minus the 11 carries down, but now we want to move this negative 11 to the other side, so we need to add 11 to our negative 2, because the 11s will cancel. We'll have negative 1/2 x, and then plus a 9. So our slope here at the end is still the negative 1/2 like we wanted, and now our y-intercept, if we wanted to graph this, is up at positive 9. All right, so just like the last one, I want us to, we'll figure out the slopes together. So our slope is negative 1/3 again, but if we want a perpendicular slope, it needs to be a positive because the signs need to change, and now you need to flip your fraction. So it's going to be a 3/1 or just a 3. So when you put it in your equation, I've given you the first number. Your coordinate is still negative 3, but now I want you to write out what this equation is going to be for point slope form, and then I want you to tell me what is your slope-intercept form equation going to be at the end as well. To fill in our numbers, you should have, then your y value should be a negative 3, so this became a plus. Your x value is just the 3. So there's your equation for the first answer. Now if you distribute, we get a 3x minus 9, and the left is still y plus 3. But then we subtract the 3 from the left to the right. So the 3's cancel. Our 3x is still there, and then negative 9 minus 3 more is a minus 12. So there's your final answer on that one. For your slope-intercept form, your slope is still 3. The y-intercept then is a negative 12.